this is Russ Andersson. Welcome to part 9 of our 360 VR tutorial. Now, earlier we inserted a building onto the ground over here. And in this tutorial, we're going to work on something closer to the camera, much closer to the camera, in fact, so that we need to pay a little extra care in that case. In this case, we're going to do a balloon, hot air balloon, and fly right on by that. So we're going to start just by bringing in our balloon, and it's sitting in a pre-assembled little SynthEyes scene file, and we're going to reparent that a little bit. Just get rid of the shot that it came in on. Okay, so we've got our balloon is there. Now it's currently sitting down there at the origin. One other little detail that we need to do on this. We'll go over to the solver panel for a second. We do need to get that world size value to be 1,000 here also. We could do that actually from with the main camera selected as well. Since if we change it in the main camera, it would affect the object attached to it also. But we just fix it up there. So we are good to go on that. So let's go down and look at what we've got. I'm going to just shut off the trackers there. And you notice the balloon's actually much larger than the building. And that's clearly not a great idea. So we need to rescale this before we start repositioning it. So I'm just going to show some of the things that happen there. Let's move this here. I'm just going to lock it up even. And here's the whole balloon. So the rescaling in SynthEyes is normally used in kind of some other situations. So I'm going to actually go and turn on the hole. This is used normally to rescale an entire object path closer or farther away from the camera. And if I start out doing this, you'll see that the object marker moves, but the meshes do not, which is good for coordinate system setup. But there's a little flag for that we want to just put it to hole effects meshes, so that, and depending on your system defaults, that may already be that way. So now we can start scaling things down to some better looking sort of size. And you notice that scaling closer and further to the camera so that the size of the balloon and the image over here stays the same. And that's what is so useful in scaling objects normally. So we've got it, it's sitting up here, maybe looking like a better size. So I'm going to turn off the hole and just switch down to the move mode, and we'll bring that down and take a look there. So we've got some office doors there. So that looks maybe like a better size. The balloon's still pretty big, because they are big, and though the size of the people looks reasonable compared to the ground floor of the building there. So now we can go and position it. So we're going to actually put it out here. Right now it's sitting there. We're going to bring it up right close to the end of the path there. Be the big finish. And now we're going to bring the height up so that the height of the gondola of the balloon is right up near the height of the ultralight as it flies on by. So that should be kind of fun. And one other detail to get right is that we want to have the person on board there looking off towards the ultralight there. I'll point out we're really pretty close. That may not be the best place to fly if you're really doing some flying there. Maybe we'll move him a little bit further away. And let's just go and rotate him. So he's facing over that way. Now we'll run out there by the end. So let's go. And there he is as he goes by. Now you notice if we let this happen, we're going to need a little bit of roto work there. So maybe let's just move him a little bit. Up that way. So hey, you know, we have artistic choices. We might as well make them that make life easier. So there we go. We've got our little plane is going to fly right by our flying balloon. So let's go now and look at this a bit larger. And I'm going to set the camera up right around here. You know, it's just, I want it just to reach the edge of the screen here. And now I'm going to roll back in time. So here it comes into the screen. And let's actually do this. Now we don't need that little marker. So that comes right over. And I'm going to set the playback to run at normal playback speed and just let this go. And if you look, you know, there's a fair amount of bouncing to that whole process. So that is due to the object that we're inserting being so close to the camera. The closer it gets, the more noise it is. I call it a noise amplifier. You know, if the jitter in the camera path is up and down 2 feet, and you have something that's only a foot away, all of a sudden it looks really bad. If it's jittering up and down 2 feet and it's 100 feet away, then that's a much less noticeable sort of effect. There's not very much happening. So in order to have a nice smooth looking path to it, we are going to want to do something about that. And the art to this is to fix that problem without creating other problems. So let's just roll over here. Well, actually, we'll take one of these panes and we will make it a little graph editor. And we'll look at the different channels. You know, so you can actually see the jitter in the reconstructed camera path. And there's always going to be some noise to it, no matter what. That's just part of reality and part of science and measuring things and so on. So the idea again is to make it not be an issue, and we're going to need to do a little bit of filtering to do that. And I do hate filtering because people just want to, you know, pound it in there and filter everything away, but that's guaranteed every time it's going to make the solution worse, because SynthEyes has already worked to find the best possible solution to the data that's presented, the solution with the lowest error. So anytime you go and add filtering, you're going to a higher error, a worst solve. But sometimes, like here, that's a necessary evil. Now, you can notice in this also that there's these periodic spikes. You see, it starts out on the one channel, then on the other, And most likely that's due to a retiming of the shot, probably from 24 frames a second or 25 frames a second down to 24. But, that's just down in the source material. So we're just going to need to deal with it like it is. To do the filtering, we're going to switch to the controller over on the solving panel. And here's the key point. We want to be sure that we're filtering the camera. And we'll bring up this panel to do that. So we're going to select the X, Y, and Z channels. Now you notice there are a bunch of controls for the frequency and the strength of this, and you can animate those over the length of the shot so that you can do more filtering in some sections and less in others. In this shot, maybe I do more filtering here on the Y in the beginning of the shot and more on the X later in the shot, but that's really being excessive. So I'm just going to use the default settings. And, the good thing about this shot is that the paths are really very smooth. The places where filtering gets you in trouble are where there are much more dramatic shifts in what it's doing, sudden shifts from one motion to another, and the filtering smooths out those shifts, and you'll see very large errors right at those periods in time. A small mistake here. Before we do the apply filtering, the filtering actually applies to the active tracker host up there, not just to whatever happens to be selected. So we need to switch to the camera 1, it's the active tracker host, and restore the channels that we want to have filtered. Now we can go and run the filter, and you see that we've got a much, much smoother path. But the acid test of that is now what we have in the way of an actual path. So let's just let that fly on by. And you can see it goes by, and it's still got some motion to it, but it's much smoother. And you're not trying to produce something that's an exact straight line. If you go overboard with the filtering, that's another problem. You can make something look very robotic. So you're looking for a nice balance in what you're doing with the filtering. Now, we've cleaned up what the balloon is doing across here, but we also need to go and look at what we've done before, and you want to make sure that it hasn't had too much of an impact. Now with what we're doing separate renders, so that's less of an issue. But, this definitely has caused a little more bounciness to the building over there. So we might want to go and back that filter back down a bit, use a smaller strength value or a higher frequency if we were going to be rendering them all in one pass. So you have to be careful with what you're doing with the filtering. As I say, it is very dangerous. It does create sliding. It does make your solve worse. But nonetheless, it can help out in situations like this. So at this point, we are ready to go and start doing our rendering for our balloon object. And to do that, we could go over and do that with Blender and the cycles renderer, and I'm sure do a really, really awesome job with flames from the burner of the balloon illuminating the inside of it. And that would be great, but we don't really have the time or the knowledge to do that right off the top of our head. So we're just going to use the run-of-the-mill approach of using Blender in its traditional perspective view mode using their regular renderer. So in order to do the follow mesh here, if you look at what we've got, if we do a follow mesh on the balloon, we would get just the top of it. It's 3 different sections plus the passenger. So we actually just want to go and select not only the top, but also the very bottom part as well, so that those are the two areas that are used to compute what section needs to be rendered. And there's no need to include the passenger or the rigging and burner part of this for the follow mesh process. That would just slow down the calculation time. So with those two things selected, let's go and run our follow mesh and let that go. So it's going to go figure out how to make a nice renderable perspective camera that exactly tracks along with the scene, with the meshes. So let's switch back over here. So now there in the camera view, you see the balloon coming right at the camera, just filling this image. And that's pretty much right, the final frame there. And we avoid the roto of the wing. Perfect. So that is just about ready to go. One other detail to this. Let's hop over to the 3D panel, and there's the building here. We don't need that in Blender for this pass, so we're going to just make it not exported so that we don't have to delete it there in Blender. We don't have to render it there or anything. So now we're ready to go. And again, it's going to just run that and magically pop up in Blender. And we do need to go and remove this screen that SynthEyes provided, which isn't particularly helpful here. And now here's the scene in Blender itself. We need to do another little adjustment though, just for Blender's rendering. You notice that the canopy of the balloon there is very faceted, so we just need to have it smooth out the normals. For whatever reason, Blender doesn't pull in the normals nicely. It may be that I'm not sending them to them, but I think that that it's not really keen on that, on receiving the normals in the first place. So we just need to smooth that out, and that way we'll get some nice looking images. And now we're ready to set up the render part of this. We need to get our transparent, and we need to be sure that we get our alpha channel coming out of this. Well, there's our output. And now we should be ready to go render. So off we go. And again, this makes quite good time at this. And, clearly this is something, anything could do in real time anyway. But here it's doing all the saving away to disk and generating these cute little displays with flashing windows and so on. So it'll take just a little bit to go through and render these. We get to see the balloon approaching, and as since the camera is animated in path in Blender, you see that the camera is actually flying around the balloon as the balloon is approaching. So it's a kind of elaborately choreographed move to come out looking good in the final ultimate composite. So now you're starting to be able to see the passenger is there. And he's waving. And he's starting to go back away. So there, we're done with the render in Blender. We've got a whole sequence of frames out on disk. And now we can hop back into SynthEyes. And now we're going to run that linear conversion process in reverse. So we're going to do the shot, change shot images. We're going to tell it we want to reverse the preprocessor. So instead of converting 360 VR to linear, or linear perspective, we're changing from the linear perspective back to VR. And we're going to select the images that we just rendered out. Those would be those balloon images there. We do want to keep the alpha channel. Again, don't want to lose that thing. And now you see, as we initially bring it in, it's still matching up with the original footage. So we're going to just go and run the unfollow script. And now everything is matched up nicely. That just rendered image is sitting there behind the wireframe. So everything is synced on up. And those are the images now that we are ready to save away. So I'm going to hit P here to bring up our image preprocessor. I'm going to go to the Output tab. And we're going to call up our output location. And this time, again, we want to be sure we don't want to include the meshes, except if you're generating some check images for people who like to check up on these things. I know people generate wireframe overlays for test, demonstration purposes often, but we don't want the meshes for the final stuff. We do want the alpha channel, and now we just let it store those reconverted images back away to disk. So now we've got another layer of the shot that we'll be able to just composite up later to form our final VR shot. Thanks for watching.